Hello everyone, this is part 3 of organic chemistry for class 10. In this video, we are going to cover following topics, that is, difference between organic and inorganic compounds and representation of organic compounds. Organic and inorganic compounds can be easily differentiated on the basis of following properties. First one is composition. Organic compounds are composed of few elements only like carbon, hydrogen, oxygen, nitrogen, sulfur, phosphorus, halogens like chlorine, bromine, etc. Inorganic compounds, these are composed of all the elements. Second property is on the basis of nature of compound. Since organic compounds are formed by sharing of electrons, that is why these are covalent in nature. Whereas inorganic compounds are formed by transfer of electrons, that is why these are electrovalent or ionic in nature. Third property is melting and boiling point. Since in case of organic compounds, the force of attraction is less, that is why they possess low melting and boiling point. In case of inorganic compounds, because of the presence of strong electrostatic force of attraction, their melting and boiling point is high. Fourth property is solubility. Firstly, solubility in water and secondly, solubility in organic solvents. So, organic compounds, these are generally insoluble in water whereas soluble in organic solvents. Inorganic compounds, these are soluble in water but insoluble in organic solvents. Still exceptions are there, and this property is on the basis of the fact that like dissolves like. Like if you are having ionic compound, it will be soluble in polar solvent, and if you are having non-ionic or non-polar type of compound, it will be soluble in non-polar solvent. Our fifth property is conduction of electricity. So, organic compounds are generally non-conductors of electricity, whereas inorganic compounds, these are generally good conductors of electricity. Still exceptions are there. Next one is combustibility. Organic compounds are generally combustible in nature, whereas inorganic compounds are non-combustible in nature. Seventh one is on the basis of volatile or non-volatile nature, that is volatility. So organic compounds, these are volatile in nature, that is they can be easily converted into vapors form, whereas inorganic compounds are generally non-volatile in nature. Eighth property is catenation and isomerase. This catenation and isomerase is easily exhibited by organic compounds, whereas inorganic compounds do not show these kind of properties. Now covering representation of organic compounds, these compounds are represented by following formulas. First one is molecular formula, second is graphic formula or open structural formula, third one is structural formula, fourth one is condensed structural formula, fifth one is bond line notation, and sixth one is polygon formula. Our first formula is molecular formula, which represents the actual number of each kind of atoms present in a molecule of the organic compound. For example, if we are taking ethane, it contains 2 carbon atoms and 6 hydrogen atoms. So its molecular formula will be C2H6. For ethene, its molecular formula is C2H4. And for ethyne, its molecular formula is C2H2. Our second formula is graphic formula or open structural formula. Graphic formula is the detailed representation of the molecule showing all the atoms and all the bonds through which these atoms are linked together in the molecule. As we can see in our first example, that is ethane, there is presence of carbon single bond carbon. Now, since we have to satisfy 4 valencies of both the carbon atoms, we are going to attach 3 hydrogen atom to each carbon atom. Since it is graphic formula or open structural formula, we have to show all the bonds present between carbon-carbon and also between carbon hydrogens. In case of ethene, there is presence of double bond between carbon-carbon. So each carbon are satisfied with 2 valencies. Now, for satisfying rest of the valencies, these 2 carbon atoms are attached with 2 hydrogen atoms each. In case of ethyne, there is presence of triple bond between carbon-carbon, so only 1 valency for each carbon atom is left unsatisfied. That is why we are going to attach 1 hydrogen atom to each carbon atom. So in this way, we are going to make all the bonds between carbon-carbon atoms and carbon-hydrogen atoms. Our third formula is structural formula. In case of a structural formula, only carbon-carbon bonds are shown and carbon-hydrogen bonds are not shown in this formula. As we can see in our first example, propane, there is presence of single bond between the carbon-carbon atoms. In case of propene, there is CH3, single bond CH, double bond CH2. In case of propyne, there is CH3, single bond C, triple bond CH. So we are going to show only carbon-carbon bonds in case of structural formula. Our fourth formula is condensed structural formula. In this case, carbon-carbon single bonds and carbon-hydrogen bonds are not shown in the formula, whereas carbon-carbon double bond and triple bonds are shown. As we can see in our first example, that is propane, since there is presence of only single bonds between carbon atoms, that is why we are not going to show those bonds in this case. Simply we are going to write down CH3, CH2, CH3 without showing single bonds between carbon or hydrogen atoms. In case of propene, since there is presence of double bond between carbon-carbon atoms, that is why we are going to write down CH3, CH, double bond CH2. In case of propyne, we are going to write CH3, C, triple bond CH. So we are showing only double and triple bonds in case of condensed structural formula. Our next type of formula is simply a bond line notation formula. In bond line notation, carbon and hydrogen atoms are not shown and only the bonds are represented. A single bond is represented by a single line, a double bond is represented by 2 parallel lines, whereas triple bond is represented by 3 parallel lines. In the bond line notation, the interaction point of the lines represent carbon atoms with appropriate number of hydrogen atoms satisfying its valencies. As we can see in our first example, benzene, there are 6 carbon atoms and 6 hydrogen atoms, but we are going to make only bonds, single line for a single bond and double line for a double bond. In case of propene, there are 3 carbon atoms and 1 double bond. That is why we are going to make a straight line and a double line. Each interaction points here are showing carbon atoms. Our sixth formula is polygon formula. Cyclic compounds are usually represented by polygons without showing carbon and hydrogen atoms. In a polygon formula, each corner of the polygon represents a carbon atom. As we can see in our first example, there are 3 corners. It means it contains 3 carbon atoms. Since the compound is cyclic in nature, we are going to start the name with cyclo. Because of the presence of 3 carbon atoms, we are going to write down prop. And since only single bond is present between carbon atoms, we are going to write down ane. So it will be cyclopropane. Our next compound contains 4 carbon atoms and single bond between carbon atoms. That is why it is named as cyclobutane. In our next compound, there are 5 carbon atoms. That is why it is named as cyclopentane. In last one, there are 6 carbon atoms as there are 6 corners. That is why it is named as cyclohexane. Now taking example of butane or but1-ine and representing it by different formulas. First one is molecular formula, which is C4H6 for butane. It means there are 4 carbon atoms and 6 hydrogen atoms in butane. Second one is graphic or open structural formula. In this case, we are going to show all the bonds, that is bonds between carbon-carbon atoms as well as bonds between carbon-hydrogen atoms. Third one is a structural formula. In this case, we are going to show only carbon-carbon bonds and not the carbon-hydrogen bonds. In case of condensed structural formula, we are going to show only triple bond between carbon-carbon atoms and no bond between carbon-hydrogen atoms or the single bond between carbon-carbon atoms. The fifth one is bond line notation. In this case, we are going to make only bonds. A single line is representing single bond, whereas triple line or 3 parallel lines are representing triple bond. Now representing benzene by different formulas. First one is molecular formula, which is C6H6 for benzene. It means there are 6 carbon atoms and 6 hydrogen atoms in benzene. Second one is graphic formula or open structural formula. In this formula, we are going to show bonds between carbon-carbon atoms as well as bond between carbon-hydrogen atoms. As we can see in the diagram, there are 3 double bonds alternating with 3 single bonds. Since valency of carbon atom is 4, that is why we have to attach each carbon atom with 1 hydrogen atoms. In this way, all the 4 valencies of carbon atoms in benzene ring is satisfied. Third one is structural formula. In a structural formula, we are only going to show bonds between carbon-carbon atoms. We are not going to show bonds between carbon-hydrogen atoms. And in bond line notation, we are not going to make any atom. We are simply going to make bond lines. Single line for a single bond and 2 parallel lines for double bonds. Thank you for watching this video. Please like the video, share it and subscribe to my channel. Thank you.